Hello, everybody. Today we're going to be reviewing in session 7 here, geometric underground structures, as you can see on the cover of my book here. This would probably be considered a geometric structure too, this hex shape. A cylinder, or in this case a half a paraboloid, is a geometric structure. It's relatively thin. This is probably an inch, if I remember right. This is an inch thick. And this is me standing here. This is in 1978, I think. So this gets its shape by the surrounding earth and keeps its shape by the surrounding earth. This is another geometric structure. This is a ribbed structure. And this also this is very, very strong. But it's still, you have to make sure that you backfill this evenly and keep even pressure. You backfill this in 18-inch lifts all the way around and you keep on going up. But it's a geometric structure, is a thin wall structure. They're very efficient. And they can be shipped in pieces. This is a 60-foot diameter dome complex. This has got some of the Cat 25s, which you saw in some earlier videos, and a 60-foot diameter dome. This also is a scalloped spheroid, is actually what it is. It's very strong. It's a composite material, so there's no radar signature here. And this is how we installed it. It was installed by another company, not by my company, but this is the dig out for it. And then it was bermed over. You can see about where this is going to be. We set down a fiberglass tray before we fill it full of concrete. Fiberglass rebar instead of steel rebar. So this has no radar signature. So this is all filled up. This is 3 feet deep here. And you can see the scale with the two guys up here. So this is a very strong structure, designed for 100 people in severe environments. This is another geometric structure. This is not round. This is actually it's squared off round. There are radiuses here. There's a radius here, radius here. Anything because it's in compression, you want anything to stop a flat surface that can buckle in. So that's the goal of all these geometric structures, is to get away from that flat surface so it doesn't buckle in or snap in. The material is a structural composite. And you can see here, it's hard to see the flame, but there is a flame there. This is 30 minutes. It's corrosion proof, it's waterproof, it's radar transparent, it's light. It can be made bullet resistant with a couple different additives in the laminate. And the E value is a modulus of elasticity. The strength material is 2.5 to 6 million. As a reference point, wood is about 1 million when you use it for designing structures. Bathtub fiberglass is about 150,000. It's really low. Steel is about 29 million. The negatives are it's expensive, and it requires molds to be made in order to make something like this. And anytime you put an underground structure in, you always want to call DigSafe. You're required to do that by law. That can be a criminal violation. So you don't ever want to forget to do that. Even in places like this, you can call them and you can tell them where it is. If it's too far out of town, they'll tell you we don't need to be there. But there's too many things that you can hit. And you have to confirm that there's the gas lines, TB lines, communication cables. One time we had actually put one in because it was way out of town, but there was a 4-foot diameter petroleum pipe about 10 feet below ground, and we had to move the whole hole over. So it wasn't on the plat drawing. So this is something that you always want to be aware of, because as soon as you As soon as you violate this and you cut someone's gas line, TV line off, you're going to have 1,000,000 people on this job site, and the secrecy of your shelter is going to be blown. But here's the problem, and I see this in the industry a lot, especially for culvert shelters. The military stopped using culvert shelters in the 60s because they have a catastrophic failure mode and they leak, and they're just not a good structure. They were never intended to be used to house people. There are some plate structures that are really thick, and you could use those, but they're just not used anymore. What you want to do is, when you do this and backfill this, you want to backfill this in lifts, 18 inches all the way around, go up another 18 inches all the way around, and you got to keep this round structure. If this is a round culvert or round structure, you've got to have uniform backfill, and you have to maintain pressure on this and check the dimension across here. I see this a lot too. Someone was careless, wasn't paying attention. And you have an uneven spread. The pressure rating of the shelter goes way down when this is not round. And what you always want to do when you install any shelter, especially round ones, especially culverts, is set up a pipe gauge vertically and horizontally, and check this measurement about every 10 feet and keep this thing round. So here's 18-foot lift, 18-inch lift, 18-inch, 18, and evenly backfill this. But every 18 inches, check this dimension. You know, the dimension when you start, this horizontal dimension should be the same as the vertical, and it should be kept within that. The tolerance is 2%. So when you backfill this, you want to keep this dimension within 2% around. So if this is 120 inches across here, 10 feet, you want it within 2.5 inches. That's the maximum that you want this to spread. When I install them, I get them about 0.5%. I get it within about 1/2 inch. And if it's spreading too far, then go back and compact this and push this down, it pushes this in. But you got to keep this roundness. Pipe gauges are easy. It doesn't take that long to put them in. You can duct tape them to the wall, ceiling, floor, all this, and you can put these about every 10 feet. It just so happens that the 1.25, 1.25 inch Schedule 40 pipe fits inside a 1-inch pipe, and you can make these markings on here before you put it up, so you know where you are. So it actually works. This one, the one on the right, is the starting one. This one, it's moved in 1/2 inch. You can put a pipe T gauge on there too. It's the same thing. If you want to hold something up in the middle so it doesn't fall down, you can do it this way. Square structures with flat walls are a little bit different because it's not relying on the strength of the soil to maintain the shape. There's usually beams here. So I still do it. I still put these on here just so I know where we are. But when you get this type of structure, this doesn't move even 1/16 of an inch. What you should do is about every 10 feet, put these pipe gauges on here. I've inspected a lot of shelters over the past 40 years that have failed. Anything below 2.5% deflection means it's starting to fail. So what happens is you get this is a straight line here. Instead, you get a long deflection across here. And some of the ones I inspected are over 1 foot, which means they failed, and you shouldn't be going in it. And that means that they failed to compact all around the shelter. It's just a sloppy installation, and they weren't paying attention. But there's people in here. You have to pay attention. Anytime you see an underground tank installed, they usually put P-stone around it, which is self-compacting. You don't have to worry about that. So this is really critical.